Hello everyone, and thank you for watching our Introduction to Airflow webinar. My name is Eric Bensala. I am an Energy Advisor for OPPD. If you have any questions by the end of this webinar or would like to learn more, please feel free to send me an email or leave me a voicemail. In today's webinar, we'll start out with some airflow definitions to get us on the same page. Then we'll talk about how air moves and jump into duct and air sealing early on. From there, we'll get into the workings of airflow balancing and close it all out with a look at some resources. Airflow is a complex and intricate subject, so we will do our best to avoid getting too far into the weeds with this introductory webinar. Let's start ourselves off right with some definitions. The Oxford Dictionary has airflow as a noun defined as the flow of air, especially that encountered by a moving aircraft or vehicle. All right. That makes sense, but doesn't quite line up in the realm of building science. So, looking at the definition from the Office of Energy Efficiency and Renewable Energy, they put it as, in simplest terms, air needs an opening or hole to flow through and a driving force to move it. To expound on these definitions, there are two forms of airflow, controlled and uncontrolled. Controlled airflow is generated by a mechanical device, such as a blower in the furnace, fans, ventilation systems, etc. In other words, controlled airflow is intentional. Uncontrolled airflow is any flow of air not designed to occur in and or out of a building, such as wind and even the stack effect, which is the way infiltrated air into a building affects the pressure of the building at different heights. The most common source of uncontrolled airflow are, of course, building leaks. Let's see just how air moves. The main areas of interest with airflow are pressure, leakage, holes in pathways, and the effects of airflow. Pressure in a home is caused by winds, fans, the blower, as well as heat. Leakage refers to duct leakage specifically, such as from your supply and return air ducts. This also includes areas where the ductwork may leak to the outside, in the case of ducts that are in unconditioned spaces like attics and crawl spaces. Holes in pathways, simply put, are areas where the air of the home leaks to the outside and vice versa. These can be designed holes like exhaust fans or non-designed holes like a leaky window. Lastly, the effects of airflow create situations in the home that can cause discomfort, from leaky windows, moisture that can lead to mold growth, combustion issues if a home begins to depressurize or the return ductwork is leaking into unconditioned spaces, air pollutants, and more. We will cover these more in depth in a later webinar. With the four main areas of interest when it comes to how air moves, let's see what we can do to mitigate those issues. Not all homes have exposed ductwork like you see here. Generally, ductwork will be exposed and accessible in utility rooms by the furnace and throughout crawl spaces and attics. If you have an unfinished basement, it's very likely you'll see duct runs there as well. Any joint or seam you can see, some examples are highlighted in orange on the right, are areas where you'll want to seal the duct to prevent any air leakages. This also applies to circular duct piping as well as the return air duct. As you can see here, this is what those seams should look like when they've been sealed. This reduces any conditioned air loss to unfinished areas, which can not only cause pressure issues, especially with the return air ducts, but can also cause inefficiencies and discomfort when it comes to heating and cooling your home. What you seal your air ducts with is incredibly important. Aluminum duct tape or duct mastic paste are the main ways to seal your ductwork. Which one you use depends on the surface of the duct, angle, and width of the potential opening. Aluminum duct tape can be easily torn to size with your hands and is considerably thicker than a sheet of aluminum foil. This method of sealing works well for square, rigid ducts like you see in the image here. For circular pipe, duct mastic paste works best. It applies wet and has a consistency somewhere between wet concrete and putty. It does take a little bit to dry, but when it does, it provides a great bit of sealant for any potential leakage spots. With this type of sealing, keep in mind you'll want to be sure to apply enough of it to completely seal off any leaks. Due to the consistency, it can sometimes separate while it is being applied, leaving tiny holes. Now, let's look at what you should not seal your duct with. Despite its name, regular duct tape is not to be used. It is essentially cloth duct tape. Cloth duct tape can hold moisture, which, as we learned earlier, can lead to mold growth. Some other types of tape not to use are Scotch tape, masking tape, and even gaffer's tape for the musicians and drama folks out there. What it really comes down to is this: do not seal your ductwork with anything other than aluminum duct tape or duct mastic paste. That's what they're designed for. We won't be getting into duct insulation here, but be on the lookout for it in a later webinar. The reasons for sealing ductwork can seem somewhat obvious, but let's unpack them a little bit here. Anytime we reduce the amount of conditioned air that leaks into unconditioned spaces, for example, attics, utility rooms, or crawl spaces, we increase the efficiency of our HVAC system to heat and cool our home. This also improves the comfort of our home. Additionally, when it comes to return air ducts, we aren't pulling in any unconditioned air from attics or crawl spaces into our living spaces. This, again, leads to a decrease in comfort and a decrease in our HVAC system's efficiency. A loss of comfort and a loss of efficiency ends up in an increase in your utility bills, both gas and electric. Furthermore, adequate sealing of your ductwork can help alleviate pressure issues that could lead to backdrafting. For more information on backdrafting, see our webinar on health and safety. We now understand some definitions and context of airflow as well as how to seal for duct leakage. Next step is to understand how to balance that airflow. When it comes to balancing the airflow in our homes, using our hands to feel the amount of air coming out of a register does work to some degree, but it doesn't give you much for a quantitative comparison. However, there is a device called an anemometer that measures the speed of the air leaving a supply register or entering a return air register. Anemometers are incredibly sensitive to airflow. Simply taking them out of their packaging will cause the fan inside to move. These devices measure airspeed in various forms. Most also measure the temperature of the air coming out or into the register. They also come with various other programmable functions to help you determine how one register is performing in comparison to another. The two main methods for balancing airflow in the home come down to either using dampers or using registers themselves. Dampers are placed directly inside the ductwork. They act like doors you can open and close to allow air to flow into that particular takeoff, which feeds to a room in the house. These are the best solution to balancing airflow. Their effectiveness is due to their being placed closer to the source of air versus registers. Unfortunately, not all homes have dampers. If you see a lever or a wing nut in the ductwork, that's a damper. If not, you likely do not have them and will need to resort to using the register itself. Registers are the second best and often the only option. They're more effective in either a closed or open configuration, though depending on how the takeoff or the duct is positioned, some subtlety to how much it's opened or closed can be effective. Let's look at a visual example of how these affect airflow balancing. Here I have labeled the parts of the ductwork for reference. There is the main trunk line and then two takeoffs that come off that main trunk. At the end of those takeoffs are the registers. Dampers will be positioned at the point of the takeoff where you see the circles on the diagram. This means the air will enter from those points off the main trunk line. If you were to close takeoff A in this diagram, takeoff B would then receive all of the airflow. If you were to close B, however, only a little air would pass by A before going into that takeoff, but the vast majority of the airflow would go through A first. Now, with registers, as you can see, if we close register A, air is still going to flow into the entire takeoff while some of it will pass by and go to B. Similarly, if we close off register B, much of the air will still flow to A because it's first, but some air will still pass by and go all the way through the takeoff into register B. And putting these two methods side by side so you can see the airflow situation by comparison, opening or closing dampers can move air to another takeoff sooner than opening or closing registers can. Here are a few tips to keep in mind when you are balancing the airflow in your home. If you use an anemometer, use a notepad or app on your phone to track the numbers from room to room. Keeping before, during, and after numbers handy during that process will help you even out your airflow easily and increase the comfort of your home. Second, save that data. It's helpful to keep this for historical and quality purposes. That way you can keep track of it over time. Next, if you do have dampers, mark where they should be for each season or time of year. For example, a winter position and a summer position directly marked on the ductwork. While you test and measure airflow, try and make sure you know exactly where the takeoffs go and if there are any additional lines or ducts coming off that takeoff. Some of these singular takeoffs can feed more than just one room. Lastly, whenever you balance airflow, this can create a pressure change in the home, but that is depending on how much you changed in terms of what rooms get what airflow and how much. With the airflow in your home balanced, you can expect to have a more even temperature throughout, making you more comfortable. Whether you have a ranch, split level, or two-story home, ensuring the airflow in your home is balanced will help even out the temperature in each room. This balance helps reduce energy usage. Instead of going to the thermostat to turn up the heat or turn down the air conditioning, balanced airflow in the home can make that uncomfortable bedroom or living room as comfortable as you need without having to change the thermostat to do so. Also, a home with a well-balanced airflow profile will help mitigate humidity in the home. While it doesn't solve for humidity issues entirely, it is a step in the right direction. To close things out, let's take a quick look at some additional resources. Our energy efficiency webpages at oppd.com/ee have a lot of information about energy efficiency. We have tips page broken down by topic, do-it-yourself videos, an interactive house to learn more about what you can do in each room to reduce your energy or improve the comfort of your home, and more. Also on OPPD.com are our rebate programs. We have the HVAC Smart Rebates, which gives you up to $350 rebate for upgrading your air conditioner or heat pump to either a 15 or 16 SEER. And our Certified High Performance Homes, or CHPH program, which offers up to $250 in rebates after having an energy rating performed to determine your home's HERS score. For more information about these two programs, visit our website at oppd.com, and under the residential drop-down, you'll see products and services. Lastly, if you are looking for a trusted contractor to help you with any home improvements, you can check out our Trade Ally information at oppd.com, Business drop-down menu under Products and Services. This concludes our introductory webinar on airflow. Thank you for watching and have a wonderful day.